All right, team, welcome back. So we're talking about 11.5 today. That's the chain rule. So let's just go ahead real quick in our first video, just review what we remember about the chain rule from Calc 1. No, sorry, I always like to do cursive when I'm writing for myself. So from Calc 1, if we have, let's say, the derivative with respect to x of f of g of x, that would be f prime of g of x times g prime of x, right? Which we could write that in the Leibniz notation as df dg times dg dx. Okay, that's perfectly acceptable. So this notation is actually going to be, as we already know, sort of more useful when we come to Calc 3. Okay, so let's look at the next version. So let's say that you have, let's look at the Calc 3 version. Suppose we have z equals f of xy, and x is some function of, let's say, u and v, and y is some function also of u and v. Okay? Then, ooh, then we can take, for example, the partial of z with respect to u is going to be, now it's going to be all sorts of dependencies going on here. Okay? So z remembers f. Okay, so I could also say it's the partial of f with respect to u, which is the partial of f with respect to x times partial of x with respect to u plus partial of f with respect to y times partial of y with respect to u. You could also think of this, if you wanted to think of this in terms of like a vector, partial of f with respect to x, partial of f with respect to y, dotted with partial of x with respect to u, partial of y with respect to u. Same thing, so it's kind of similar to the directional derivatives, okay? Similarly, partial of f with respect to v is partial of f with respect to x times partial of x now with respect to v plus partial of f with respect to y times partial of y with respect to v. Okay? So that's just the chain rule in multiple dimensions. And in more than two, it would extend in the same way. Let's do just sort of our first sort of example. Okay? So let's take, let's suppose f of, we're going to do it the other way around. Let's suppose f of, suppose f of xy equals, let's take 3xy plus 2x squared. Okay? Now, let's suppose we wanted to understand how this changes in polar coordinates. Okay? Okay? Now, there's two ways we could do finding, let's say, for example, let's find the partial of f with respect to r. Okay, we're going to do this two ways just to sort of see what's going on. Okay? So let's do it first directly. Okay, so this doesn't take anything really from the chain rule yet. Okay, so all we're gonna do there is we're gonna say, okay, f of our theta is going to be what? 3r squared cosine theta sine theta plus 2r squared cosine squared of theta. And we could take the partial of f with respect to r. Partial of f with respect to r is going to be 6r cosine theta sine theta plus 4r cosine squared of theta. Okay. We could also do this using the chain rule. Let's do that there in blue. Let's use the chain rule over here. Okay, so if we use the chain rule, then it's going to be partial of f with respect to x times partial x with respect to r plus partial f with respect to y times partial y with respect to r. Okay, so what's partial of f with respect to x? That's going to be 3y plus 4x times what's partial of x with respect to r? That's just going to be cosine of theta, right? Plus partial f with respect to y. That's going to be 6x. Partial y with respect to r is just sine theta. Okay, now let's go ahead and make these substitutions. We're going to get 3r sine theta plus 4r cosine theta times cosine theta plus 6r cosine theta sine theta. Oh, something went wrong. My partial f with respect to y was wrong. That should have been 3x there. That makes that 3. And then we have the same thing on both sides, right? This 6r cosine theta is 3r cosine theta plus that 3r cosine theta. This 4r cosine squared theta is this 4r cosine theta times that cosine theta. Okay? All right, I'll see you all in the next video.